Okay, let's dive in. Picture this. A system handling literally millions of trips every single day across thousands of cities globally. We're talking about Uber.
Yeah, the scale is just immense.
And that scale means an absolutely massive code base, hundreds of millions of lines, supported by thousands of developers.
Right.
Now, the core challenge becomes, how do you keep that incredibly complex engine not just running smoothly, but constantly improving? And, keep those thousands of developers building new features, squashing bugs, maintaining quality, without getting completely bogged down.
It's a huge undertaking, absolutely. When you have that many engineers touching that much code, developer productivity isn't just like a nice to have, it's fundamental to the business.
Mm-hmm.
So the question for Uber's developer platform team really is, how do you build tools that actually scale? Tools that help, 5,000 engineers navigate and contribute to that level of complexity effectively?
And that's precisely what we're unpacking today. We're looking at how Uber is tackling this challenge head on by leveraging AI, specifically building sophisticated AI developer tools using frameworks like Langraph.
Yeah, and this deep dive is based on insights shared directly by engineers from Uber in a presentation. They detailed their strategic approach, the specific tools they've built, the underlying tech.
Including how they adapted things like Langraph.
Exactly, and the measurable impact they've seen, plus some really key lessons learned along the way. It's quite insightful.
So think of our mission here as giving you the fast track to understanding Uber's playbook for using AI in developer tooling. We'll explore their high-level strategy, shine a light on a couple of their standout products.
Get into the weeds, just a bit on the tech behind them.
Right. Quantify the real-world results, and most importantly, distill the big strategic takeaways, the things you might actually be able to apply, whether you're dealing with a large code base, a complex workflow, or just thinking about how AI can augment expert tasks.
It's a fascinating case study, really, bringing cutting-edge AI into a very demanding enterprise environment.
Okay, so let's start with the foundation. What's the strategic lens Uber is using for building these AI developer tools? What's the 10,000-foot view?
Well, they've structured their approach around three core pillars. The first one is what they call product bets.
Product bets.
Yeah, this is about being laser-focused on specific high-leverage areas that will directly improve the developer workflow.
So not just building cool tech for its own sake, but really targeting problems developers actually feel day to day.
Exactly. They're identifying tasks that developers do regularly but find, tedious, time-consuming, or just difficult. They call toil.
Right.
Examples they gave are things like writing unit tests, essential for quality, but it can be repetitive, or the sometimes laborious process of code review.
Uh-huh.
The strategic insight here is that to make a difference at that kind of scale, you have to bet on eliminating that toil in areas with the highest potential impact.
Automating the pain points. Got it. Makes sense. What's the second pillar?
That's building cross-cutting primitives. So as they build these specific tools, the product bets, they're simultaneously developing foundational AI technologies,
Yeah.
the right abstractions, and frameworks that aren't tied to just one tool. Think of them as reusable building blocks.
Okay, like creating a library of functions or components that any future tool can just grab and use.
Precisely. Having these shared primitives in place is crucial. It lets different teams build more solutions and critically build them much faster because they aren't reinventing the wheel every single time they want to integrate AI into a new workflow.
Efficiency through reusability.
Yeah.
Smart. And the third pillar.
This one they call intentional tech transfer. And they stress this is a cornerstone of their strategy as they develop those initial product bets and the primitives that emerge.
Reusable blocks?
Yeah, they are very deliberate about identifying components that prove to be broadly useful. They consciously package these up, make them accessible, and really drive their adoption across the organization.
So it's not just hoping reusability happens organically, but actively making it easy and, encouraging it.
Exactly right. It ensures that the investment and the learning from building one tool actively lower the barrier for the next team trying to solve a similar or related problem with AI. It's like getting compound interest on their development efforts.
That three-pillar strategy makes a lot of sense. Target specific pain points, build reusable pieces while you're at it, and then make sure those pieces actually spread.
Now, you mentioned frameworks like Langraph. How does that fit into actually building these tools?
Okay, yeah. This is where their internal framework, called LangEffect, comes into play. They described it as Uber's opinionated wrapper around orchestration frameworks like LangGraph and LangChain.
An opinionated wrapper. Why build their own layer on top of existing frameworks? What was the need there?
Well, they found a fundamental need for what they called an agentic approach to solve these complex developer problems.
Agentic, you mean like breaking a big task down? Exactly. Breaking a larger task into smaller steps. And each step is handled by a specialized AI component or agent that performs a specific action. They saw early on, when building their first tools, that these workflows involved sequences of actions and needed reusable steps or nodes. Langraph, with its graph-based structure, is really good at modeling and orchestrating these multi-step agentic processes. It's almost like drawing a flow chart for a complex AI task.
Ah, okay. So Langraph helps them map out the sequence of steps and decisions an AI system needs to take to get something done.
Yes, it's perfect for that kind of orchestration. But, and this is key, to make LangGraph and LangChain work reliably, scalably, and securely within Uber's specific complex internal systems.
Their build tools, their code repos, all that stuff.
Exactly. Their deployment pipelines, everything. They needed a layer that understood the Uber way of doing things. LangEffect provides that layer. It standardizes how these agents interact with Uber's environment and manages tricky things like state and concurrency across these graph-based workflows.
Okay, so LangEffect essentially makes LangGraph Enterprise ready for Uber's world. Got it. Strategy and core framework established. Let's look at how this played out in practice. What are some specific tools they built using this approach? What was the first product bet they highlighted?
One of the early and very successful tools they built is called Validator.
Validator. The name sounds like it's, well, checking something. What specific problem does Validator solve for developers?
So Validator is an AI-powered tool integrated directly into the developer's IDE, their integrated development environment where they write code.
Right in the editor.
Yeah. Its core job is to automatically scan the code as it's being written and flag violations of best practices or potential security issues.
So it's catching errors or potential problems in real time, right there while you're typing.
Exactly. The goal is immediate feedback, catching issues super early before they even try to build or submit their code for review. And the user experience is designed to be non-intrusive but helpful. Like imagine you're coding in Go, maybe, and you see a familiar squiggly line under a piece of code.
Like spell check, but for code practices.
Sort of, yeah. When you mouse over it, Validator provides a diagnostic message.
What kind of message? Is it just a generic, hey, this looks wrong?
No, it's specific and insightful. For instance, it might tell you you're using a particular function incorrectly for creating a temporary test file. And it explains why this is a problem. Maybe it could leak resources to the host system and needs proper cleanup, using a different pattern. It gives context and the rationale behind the suggestion.
Understanding the why is so important. Okay, and then what does the developer do? Do they just get the warning and have to go figure out the fix themselves?
Well, that's where the AI assistance really comes in. The user gets options right there. Validator, in many cases, can offer a pre-computed fix.
A pre-computed fix, like it already knows the answer.
Yeah, a code suggestion it already knows will likely resolve that specific issue based on the violation pattern. Or the developer can choose to send a request to their IDE's agentic assistant, which is powered by the same underlying tech.
And that assistant then generates a fix on the fly.
Exactly. The flow is the assistant processes the diagnostic info, looks at the surrounding code for context, and then returns a suggested code fix right there in the IDE. The developer can review it, maybe tweak it, and apply it.
And then the problem's gone.
Problem solved, squiggly line disappears, the code smell is gone. The developer fixed the issue without leaving their editor or spending ages researching the correct pattern.
That sounds incredibly efficient. So how is Validator built under the hood? You mentioned it's a Langraph agent. Is it just one big agent?
It's a Langraph agent, yes. But a really key insight they applied here is composing multiple sub-agents under that central validator agent.
Okay, so it's not one monolithic AI trying to do everything. It's like a team of specialized agents.
Absolutely not monolithic. That modularity is key. Different sub-agents are specialized for different parts of the validation task. For example, one sub-agent might interact with a large language model, an LLM.
Right.
It feeds the code snippet and a curated list of Uber's specific best practices to the LLM to evaluate the code against more complex, nuanced rules, things that are hard to capture with simple patterns.
Okay, so using the LLM for the fuzzy interpretive stuff, the complex judgment calls, what about things that are less fuzzy, more clear-cut?
That's where another crucial learning comes in. Integrating deterministic sub-agents. For things that can be checked with reliable rule-based logic, like basic syntax errors, or known anti-patterns that traditional static analysis tools or linters are perfect at finding they have a subagent that just runs those standard linters.
Ah, so using the old reliable tools too.
Exactly. This deterministic agent reliably discovers those kinds of issues, and its output is fed into the overall Langraph flow, just like the LLM's output.
So they're cleverly combining the power of AI for complex evaluation with the reliability and speed of traditional code analysis tools, all within the same orchestrated workflow.
Precisely. You use the right tool for the right part of the task. And the impact? It's significant. They reported validators seeing thousands of fixed interactions every single day from engineers.
Thousands a day. Wow.
Yeah. It's catching problems at the earliest possible stage while the code is being written, providing that immediate feedback and offering fixes, meeting developers exactly where they are, right in their IDE. It's a powerful demonstration of how combining deterministic methods with AI can provide real, tangible value.
Thousands of fixes a day is definitely a clear productivity win, but they didn't stop at just validating existing code, right? What was the next evolution?
Right. Building on those foundations, the framework, the agentic approach, the reusable pieces like Validator itself, they developed a tool called Autocover. This takes things a pretty big step further. It goes beyond just flagging issues to actively helping engineers author tests from scratch.
Ah, writing tests. The part of coding many developers find, let's say, less thrilling than writing features.
Exactly. We all know writing good, comprehensive tests is crucial for code health, preventing regressions, but it can be time-consuming and sometimes feel repetitive.
Definitely.
So the goal of Autocover is to generate high-quality tests, and they emphasized quality. Tests that cover meaningful business cases, are validated to actually pass, and are even mutation tested to ensure they aren't trivial or brittle. And do it quickly.
So the aim is freeing up engineers to focus on building new features, not grinding out boilerplate tests.
That's the idea. How was Autocover built? Did they have to start from zero again?
Well, this is a prime example of those reusable primitives and the intentional tech transfer paying off. Autocover wasn't built in isolation at all. They composed it by taking a bunch of domain expert agents, specialized agents, good at particular tasks within the software development lifecycle and orchestrating them using Langraph.
Domain expert agents.
Yeah, and crucially, they explicitly mentioned that they included the validator agent itself as one of the domain experts contributing to the test generation process.
Wait, hold on. The tool that flags errors is now part of the system that writes the tests. That's a fantastic example of reusability in action.
Isn't it? It really shows how powerful it is when you encapsulate functionality in a reusable agent. Validators' knowledge of best practices and potential pitfalls is valuable context even when you're generating new code, like tests.
Makes total sense.
And the user experience for Autocover, again, is designed to be simple from the developer's perspective. You might be in a source file, you right-click, and maybe select an option like bulk generate tests for this code.
And then the AI magic happens behind the scenes. What does the developer actually see?
Well, a lot happens behind the scenes, orchestrated by the Langraph agent. It starts by interacting with Uber's build system to set up the whole environment for testing, maybe creating an initial empty test file.
Okay.
It runs an initial coverage check to see what, if anything, existing tests already cover. And crucially, it analyzes the surrounding source code, looking at function names, comments, the code structure itself, trying to understand the business context. What is this code supposed to do?
So it's not just generating tests based on code structure alone, but trying to infer the actual requirements or intent.
Yes, exactly. It's aiming to write meaningful tests that reflect how the code should behave from a functional perspective, not just syntactic coverage. And what the developer sees next is actually quite dynamic. They get switched over to the newly created test file, and it starts in what they described as a state of constant flux.
Constant flux. What does that look like? Is it just code appearing randomly?
Kind of. You see test cases appearing in the file as the generator agent comes up with ideas. But simultaneously, the executor agent is busy in the background, interacting with the build system,
Right.
building the code with the new tests, running them, checking the coverage results. If a generated test doesn't compile or fails, poof, it gets removed. Tests might be refined or merged if they're redundant. New tests appear, aiming for higher coverage or addressing specific business cases identified by the analysis. The file is literally being continuously updated until the agents collectively determine they've arrived at a nice set of validated, vetted tests. Wow, that sounds like a really complex, iterative process happening automatically. How did they structure the Langraph for something like that?
The graph structure essentially mirrors the logical steps a human engineer might take, just automated and parallelized. There's typically a scaffolder agent that sets up the environment and identifies potential test scenarios or business cases based on that source code analysis.
Okay, the planner.
Then a generator agent actually comes up with the code for the test cases. And a powerful executor agent handles all the interaction with the build and test systems, running the builds, executing the tests, gathering the coverage reports.
And the graph orchestrates the cycle. Scaffold, generate, execute, evaluate the results, feed that back, and repeat.
Exactly. And because there's no human sitting there waiting during this loop, they realized they could, as they put it, supercharge the graph. This led to a really key performance insight.
Supercharge. How do you supercharge a graph? More agents.
Through massive parallelism, basically. For large source files, they found their executor agent is capable of handling 100 iterations of code generation and 100 separate test executions simultaneously.
100 at once. How is that even possible?
Because the agents are designed specifically for this domain, they know exactly how to talk to the build system efficiently, and the graph structure provided by Langraph allows them to manage that intense level of concurrency effectively.
That sounds incredibly fast and efficient compared to a human doing it one test at a time.
It is, and this leads directly to one of their most important learnings. Building these super capable domain expert agents, agents that are highly specialized in a specific area like test execution or build system interaction, gives them, in their words, unparalleled performance or exceptional performance compared to other more general tools out there.
And they benchmarked this.
They did. They benchmarked Autocover against other industry agent coding tools and found it achieved 2 to 3 times more test coverage in about half the time.
Whoa. 2 to 3 times the coverage in half the time. That's a massive jump in productivity for test rating.
It really is. And the impact is quantifiable beyond the benchmark. Autocover helped increase test coverage specifically within their own developer platform team by a significant 10%.
10% increase in coverage is huge for a mature platform.
Yeah, and they estimate this maps to saving roughly 21,000 developer hours. It's a tool that's actively used, generating thousands of tests every month.
21,000 developer hours saved just on writing tests. I mean, that number alone speaks volumes about the value proposition of these kinds of tools. So, okay, Validator and Autocover are 2 really big, impactful successes. Did these reusable components and this whole agentic approach start spreading beyond just these 2 tools? Did that tech transfer pillar work?
Absolutely. That intentional tech transfer pillar wasn't just a nice idea on a slide. The reusable primitives, the agents, the framework, and the capability to build these specialized agents started showing up in other parts of Uber's engineering workflow pretty quickly.
Okay, can you give us a few quick examples of where else this popped up?
Sure. They mentioned building something called an Uber Assistant Builder. You can think of it like an internal platform, almost like a custom GPT store.
Ah, for internal use.
Yeah, where different engineering teams can quickly build their own specialized chatbots or AI assistants for their specific domain, steeped in Uber's internal knowledge. An example they gave was a security score bot.
Okay.
This bot uses some of the same underlying security best practices knowledge that Validator uses, but it allows engineers to ask questions before writing code, like, is this approach okay? Or what's the secure way to do X?
So taking the same core knowledge base, but repurposing it into a conversational interface for proactive advice. That's clever.
Right. Another example is within their internal workflow management platform, which is called Picasso. They developed a conversational AI interface there called Genie Adopt. This AI understands their internal workflow automations and product information, acting as an intelligent guide or assistant for developers trying to navigate those complex processes.
An AI that actually understands internal company knowledge and specific workflows. That sounds useful. Any other examples, maybe catching issues later in the cycle?
Yes, they also have a tool called U-Review. The idea here is that even with Validator catching problems in the IDE and Autocover helping generate good tests, some issues might still slip through to the code review stage.
The human review part.
Right. U-Review is designed to use AI leveraging similar underlying components and knowledge bases to automatically flag potential code review comments and suggestions before the code is even merged into the main code base. It acts as an additional automated safety net during review.
Okay, so they've really built a suite of tools covering different stages of the development lifecycle, writing the code, writing the tests, getting the code reviewed, all leveraging some of the same fundamental AI capabilities and these agentic patterns. That really highlights the power of those reusable primitives you talked about.
It absolutely demonstrates the strategy working in practice. Build once, reuse effectively.
Let's pivot then to the key learnings they distilled from this whole experience. Beyond the specific impacts of tools like Validator or Autocover, what did they learn about building AI tools at this kind of scale? within a complex organization like Uber, maybe both on the technical side and the more strategic or organizational side.
Okay, yeah. On the technical side, they definitely reinforced several crucial points we've already touched on through the examples. First, building those super capable domain expert agents is really the way to get outsized results.
Specialization is key.
Absolutely. These aren't generalist AIs trying to do everything. They are agents highly specialized in understanding and interacting with specific parts of the developer's world, like code structure, test execution, build systems. This specialization gives them much better context, allows them to maintain richer state about the task they're performing.
Leads to fewer errors or hallucinations.
Right, reduces hallucination compared to a more general model trying to infer everything. And as we saw dramatically with Autocover's executor agent, it allows for incredible performance optimizations like that massive parallelism.
So the takeaway is break the problem down and build AI specialists for each piece.
Exactly. And kind of related to that, they learned that composing agents with deterministic subagents, or even making the whole agent deterministic where possible, makes a lot of sense when you need reliable output.
Like the validator using a traditional linter for the straightforward checks. Don't use AI for what a simple rule can do perfectly.
Yes, precisely. You don't need a complex LLM to find a basic syntax error. A deterministic parser is 100% reliable and much faster. By combining the reliability of traditional tools with the power of AI for the more complex, nuanced evaluations within a single agentic workflow, you get the best of both worlds. Powerful capability and predictable behavior for certain essential tasks.
Don't use a sledgehammer to crack a nut, basically. Use the right tool.
Right. And finally, on the technical side, they found they could dramatically scale their development efforts not just by building reusable primitive components, but specifically by creating reusable agents that solve well-defined, bounded problems and then plugging those agents into different larger workflows.
Like we saw with the validator agent being used standalone in the IDE and then reused as a core piece within the autocover graph.
Exactly that. And they mentioned even lower-level examples, like having a specialized agent designed just to interact with their internal build and test execution systems. That single complex build system agent becomes a dependency for both Validator's quick checks and Autocover's extensive testing loops. They build that complex interaction logic once, encapsulate it in an agent, and multiple products can leverage its functionality without re-implementing it.
Okay, so powerful specialized agents, combining AI with deterministic tools smartly, and making agents themselves reusable building blocks. Those are really solid takeaways. What about the strategic or organizational learnings? How did this project impact how teams work together or how they thought about processes?
Yeah, this is where they highlighted some potentially broader impacts. A major learning was how the structure they adopted, particularly using a well-designed framework like LangEffect, wrapped around Langraph, really facilitated collaboration across different teams. They found that encapsulation boosts collaboration.
Encapsulation meaning abstracting away the underlying complexity, hiding the messy details.
Yes, exactly. The framework handles the complexities of state management between steps, concurrency, and interacting with the core graph structure itself. This meant that different teams could contribute their specific domain expertise by building specialized agents or providing knowledge without needing deep knowledge of how the overall AI system or the graph orchestration actually worked.
That sounds incredibly powerful for a large organization with lots of specialized teams. Can you give a concrete example they mentioned?
Yeah, the best example they gave was their security team. The security experts were able to write and contribute the specific rules, patterns, and knowledge that Validator uses to identify security vulnerabilities or anti-patterns in code.
So the security folks provided the smarts.
Right. They could focus entirely on their security domain expertise and define the knowledge for the security validation agent without needing to become experts in AI agent architecture or how Langraph actually executes the flow. The framework provided the necessary abstraction layer for them to plug their expertise in.
That's a fantastic point. It really lowers the barrier for domain experts who aren't necessarily AI engineers to contribute effectively to building powerful AI tools. What else did they learn strategically?
They also realized that graphs help model interactions perfectly, often mirroring how developers already think about or interact with their systems and workflows. That wasn't too surprising. But the key strategic insight that flowed from this was a bit unexpected.
No.
They found that using AI in these graph structures to model and automate complex workflows also served as a powerful lens to reveal bottlenecks and inefficiencies in those existing manual processes.
Wait, so building the AI actually helped them find problems with the non-AI way of doing things?
Exactly. As they built the complex, multi-step agentic process for generating tests in Autocover, they had to deeply integrate with and precisely understand their existing manual workflows for things like generating mock data, interacting with build configuration files, and executing test suites.
They had to really map it out.
Right. And in doing so, they uncovered numerous paper cuts or friction points or just plain inefficiencies in those underlying processes themselves, things that made life harder for developers even when they weren't using the AI tool.
So building the AI automation exposed the hidden pain points in the manual steps that maybe everyone had just gotten used to.
Precisely. And the crucial point here is fixing those underlying inefficiencies to make the AI agent run more smoothly and effectively also directly improved the experience for developers performing those tasks manually or using other non-AI tools. It wasn't an either choice between building the shiny new agentic system and improving the existing system.
They helped each other.
Exactly. Building the agentic system became a diagnostic tool that highlighted where improvements were needed across the board, benefiting everyone.
That's a really powerful feedback loop. The AI project drives fundamental process improvement even for the non-AI workflows. It creates a kind of virtuous cycle.
It really does, a virtuous cycle of improvement.
So looking at the whole picture of Uber's experience here, the immense challenge of scale, the clear three-pillar strategy, the innovative tools like Validator and Autocover, powered by these composed specialized agents and Langraph, and then the tangible results like 21,000 developer hours saved and tests generated 2 to 3 times faster, it's a really compelling blueprint.
Yeah, it absolutely is.
This clearly wasn't just some theoretical research project. It's driving real, measurable productivity gains in an incredibly complex, real-world environment.
And it really shows that these core concepts, breaking down complex tasks into specialized agents, building truly reusable components, modeling workflows visually as graphs, are incredibly powerful tools for tackling complexity and information overload. Not just at a massive company like Uber, mind you, but potentially in any domain where you have multi-step processes or expert tasks that could be augmented or automated.
Yeah, they offer a different, maybe more structured way to think about approaching those kinds of complex problems.
Absolutely. It makes you step back and consider, how might you map out a process that you or your team currently handles manually? What are the distinct steps? What expertise is needed at each step?
Which leaves us with a final thought for you, the listener, to maybe ponder. How can you identify complex, multi-step workflows in your own world? Workflows that currently rely heavily on human expertise, and think about breaking them down into composed, specialized agents. And perhaps even more interestingly, as we just discussed, what hidden inefficiencies in your existing manual processes might be revealed simply by attempting to model and automate them using this kind of agentic, graph-based approach.
Yeah, what might you uncover just by trying to teach an AI to do it? Something to think about as you look at the processes around you.
Definitely food for thought. Thanks for taking this deep dive with us.